Lesson number 2 is on Pythagorean theorem. Now, when we look at this Pythagorean theorem, this is very, very, very specific because this Pythagorean theorem only works if we have a right triangle. So only works if we have a right triangle. Okay, so if you want to write that down, Pythagorean theorem only works for right triangle. Okay, well, stop again. What does it mean by right triangle?
90 degrees.
Yeah, a right triangle means a triangle that has a 90-degree in it, right? So an angle, right triangle means it has 90-degree angle. Okay. It doesn't work for any other triangles that does not have a 90 degrees. So, our goal for today is to calculate the measurement of the third side using the Pythagorean theorem. Third side, okay? Well, which one is the third side? Okay, well, which one is the third side? Yeah, last time we said a triangle has 3 sides. So you're going to be given 2 sides. You're solving for the third side. So, but the question is, which one is the third side? It could be any. Any side would be a third side. Okay, so let's read on. A right triangle is an angle that should be a triangle that has a measure of 90 degrees, which means 2 of its sides are perpendicular. Whoa. What does a perpendicular mean?
This way.
It looks like an upside down, like a T or an L, right? So they're perpendicular to each other. Perpendicular means creating a 90-degree angle between the 2 lines. If a triangle has 1 right angle, it is called a right triangle. So a triangle has 1 right angle, which is called right triangle. A small box is placed where the 2 perpendicular sides meet. This box means that the angle created by 2 perpendicular sides is 90 degrees. So that means this, when you see a square, it means automatically 90 degrees. Okay? So at 90 degrees, a 90 degrees is also referred to right angle. Triangle with 90 degrees is called a right angle triangle or right triangle. Now this is a trick question. Okay? Why is it impossible to have more than 1 right angle in a triangle?
Because if you were to have 2, it'd be 180, but there's another side.
But there's another angle. Yeah, absolutely. Yeah, and exactly. Very good, very good. Now you're tying what we learned in lesson 1 to this one here. So you can't have 2 right angles. So if this is a right angle, this is a right angle, and this is a right angle, this is 90, this is 90, we cannot create a triangle in that way, right? So So this, if this is 90, this is 90. That's not a triangle. So why is it impossible? So because the sum of all angles, all three angles in a triangle must equal to 180 degrees. So if you already have the 90 and another 90, that's already the 180, right? What happened to the third angle? So in a right triangle, a special vocabulary is used. Special wording, special vocabulary is used. The longest side across from 90-degree angle is called hypotenuse. So if we locate the 90 degrees and right across from it, that's called a hypotenuse. Who's heard of that word before? Hypotenuse. Hypotenuse. Okay. So
Something this is like this one, 5 one.
oh no, it's just a name. Just a name that's a different special name that's used for the side that's across from 90 degrees. So, and then the two other sides are called legs. So we have the longest side, which is the hypotenuse, and we got the two legs. So when we look at this one here, the first one, so which one is the hypotenuse? Which one is the hypotenuse? So first, we locate where the 90 degrees is. Okay, the 90 degrees is right here. And the hypotenuse is right across. Well, which one is right across? That one over there. So this is the hypotenuse. I'll just put HYP. Hypotenuse. Hypotenuse. And these two are called legs. Should be leg and a leg. Okay. Now let's take a look. Take a look at the next one. Which one there is the hypotenuse? So they twisted it around, rotated it a bit. Okay, so this is the 90 degrees. Right across from 90 degrees is hypotenuse. So this is the leg, this is a leg. Okay. So go ahead and do the next three. Okay, so the hypotenuse should be right here. This is a leg, leg. Hypotenuse is here. The leg and the leg. And where's the hypotenuse on the last one? Slanted part right here. Why do we have to bother doing that?
So we know what side we're trying to
Yeah. We gotta know which side we're figuring out. Remember, we're solving for the third side, but which third side are we talking about? Are we talking about one of the hypotenuse or is it the legs? Okay, which one is it? What do you notice about hypotenuse and the leg in relation to the angle? What do you notice about the hypotenuse?
Opposite. The two legs equal to the hypotenuse.
Okay, you're kind of okay. Now you're talking about the formula. We haven't gotten to the formula yet. Hmm? Okay, I'm sorry, I can't hear you. Oh no, we're not quite there yet. Yeah. We're not doing formula yet. But what do you notice about the hypotenuse and the leg? Well, besides,
It's the longest side.
are you convinced that the hypotenuse is the longest side?
Hypotenuse is in opposite of right.
Okay.
90 degrees.
It's the opposite for 90 degrees.
Yeah. So the hypotenuse is opposite or across the 90 degrees. Okay, Abdurrahman says hypotenuse is the longest side. Okay, both of you are correct. But are you convinced? Can you explain why hypotenuse is the longest side? And I know some of you could whip the formula, solve it, but I'm trying to get everybody to think about why is hypotenuse the longest? You know that already. You've heard about it from probably your previous teacher. Hypotenuse is always the longest side in a triangle.
Because of the straight. The line is straight.
The lines, they're all straight.
It's not.
No,
Yeah.
They're all straight though. All the lines are straight. Yeah.
Because it's probably like the largest number out of because won't the two sides equal like the same number because that's where the 90-degree angle is at?
Yeah. Oh, okay. So yeah, both of you are saying the same thing. You're getting into the formula, and yeah, you will eventually get the largest. Yeah. But I'm not doing the formula yet. Yeah.
The reason it's long is because you have to get 90 degrees. If it's shorter or longer, maybe you're not gonna have 90 degree angle.
Okay. You got it. Okay. So, do you notice that the 90 degree is the biggest angle? Yes? Do you think this is the biggest angle? Okay. I'll demonstrate something using the door, because the door is always the best instrument to use. Okay. So, I'm going to use the door. Sorry, I'm going to use the door. So you can come in.
Go ahead, Jack.
Come on in.
Don't worry about it.
Right. Okay. So, what angle is the door?
Now,
Okay. If the door is right here, and I swing it this way, what angle is the door? 90. Yeah, we'll just say 90. Right? 90. Okay. What angle is this? 0, right? Close? 0, 90, like that. Okay. If I open the door at this small angle, okay, I know some people at the back there, it's kind of hard to see, but if I open it with maybe about 20 degrees, about 30, is that 30?
yeah.
Almost. What's happening over here? It's pretty tight, right? It's pretty small. So if your angle is small, your opposite side is also small. Yes? You following? If I open it big, what happens to the opening? It's also big. So the big, because you have a biggest angle there, which is the 90 degrees, it opens to the biggest side. The biggest angle should open to the biggest side. So if this is 90 degrees, these two are going to be less than 90 degrees. So if this is the biggest angle, then it should open up to the biggest side. Now, here's the thing. This is what you have been waiting for, wanted to hear, is the calculation. This is why you showed up for class today, because you wanted to know Pythagorean theorem. So, the person who did this is called, his name is Pythagoras. He's a Greek philosopher. Absolutely. This is what some people are saying. They said you add up the two sides and then you get the third side. That's actually not true. Okay, it's not the sum of the two sides, it's the sum of the squares of the two sides. Okay? The sum of the two squares. So you square each side first and then add them up. That's a Pythagorean theorem. So it says here, the Pythagorean theorem is often written as a squared plus b squared equals to c squared, where c is the hypotenuse and a and b are the sides or legs. So let's put legs to be consistent with the terminology. Legs. So we're going to go leg squared plus another leg squared is equals to the hypotenuse squared. Okay. It's not the leg plus the leg equals the hypotenuse. It's the leg squared plus another leg squared is equals to the hypotenuse squared. Okay. So, here we go. Let's get straight to the example. Use the Pythagorean theorem to find the length of the missing side. Okay. Now, in this question, they started saying like use the Pythagorean theorem. Right? They're telling you a strategy. In the assignment and in the test, guess what it will say? It says find the length of the missing side. Okay? This one is leading you or telling you a strategy. Later on, you'll do, the question would be just find the length of the missing side. So you look at this one here. Okay? These are all three sides. Which one is the hypotenuse? X. The variable x is a hypotenuse. And what do you call these two? Leg and then a leg. Okay? Now, this is what we're going to do. First, start with the formula. And sometimes I call it a recipe. Okay? So start with the formula. I'll just go, is it okay if I go a squared plus b squared equals to c squared? We know a and the b are the legs, c is the hypotenuse. Okay. What do we do? So we write the formula down. The next step is substitution. So what are we going to substitute? So these two are the legs, this is the hypotenuse. 6.5 squared plus 8.7 squared equals to x squared. Okay. Okay. So what we're trying to do is solve for x. How do we solve for x? We've done this before. How do we have the x alone? Now this part in here, okay, with this, yeah, go ahead.
You square is worse than, and add subtracting when you.
Uh-oh. Hold on. Okay. We need to solve for x. How do we do that? Well, this part here is 6.5 squared plus 8.7 squared. We can use the orders of operation in here to do that.
We get the answer from 6.5 over 2, and we get the answer for 8.7 over 2.
Oh, yeah, exponent 2. Exponent 2.
And then you would write it down under it, and then get the answer, and then do it 2. So,
Root.
yes.
Yes, okay. Yeah, okay. So this is what Tristan is proposing. He's going to do an order of operation. What does the order of operation means? Bed mass. Right? Exponent first before we add. So this is what he said. 6.5 squared. What is it?
42.25.
42.25 plus 8.7 squared. 75.69. Okay, this is an equation. Equation has a left side and a right side equal in the middle. Yes? I'm going to always refer to that all the single time. What do we do next? We can work this out. Yeah, add them up. 117.94 equals to x squared. Okay, 117.94 is equals to x squared. That doesn't solve for x. It's x squared. So how do we get rid of the square? Opposite of square is square root. So squaring and square root cancel each other out, so you're left with the x. $10.86. So the hypotenuse is 10.86. Or 10.86 centimeter equals to x.
Wouldn't you just round it to one number though?
What's that?
Wouldn't you like just round it to one number since there's only one decimal?
Not necessarily. You round it off to 11. Yeah. So for this one here, like you mean 10.9?
Yeah.
Yeah. Yeah. It will vary depending on the question, because some of the math questions it says we'll round to 2 decimal places if necessary. Okay.
Question. What about na unit, like second centimeter?
Yeah.
8.centimeter.
Okay. That's a good question.
You are not to do the half.
So the question is, what about the units? Okay, what about the unit? Centimeters. So when we square a unit, it would be centimeters squared, right? And then when we take the square root, it just becomes a centimeter. Which makes sense because, remember, this are length. The measurement are lengths. So that's in centimeter. If we put centimeters square, That's the area. That's the area unit. Okay? I'm gonna go example number 2 and then we'll finish it off. Okay. Pythagorean theorem. Oh, it says here, find the length of the missing side. Remember, they didn't say use the Pythagorean theorem to find the missing side, right? Okay. So the first thing that you're gonna do is what? Okay. A squared plus B squared equals to C squared.
15.67 is the hypotenuse.
Okay.
So that's C squared.
Very nice. Okay. Good. Now, the next thing that we got to do, I don't want to leave everybody behind or anybody behind. This is something new to you. I want you to feel like you leave that you understand this. Which part here, let's label the sides. Which one's the hypotenuse? Which ones are the legs?
15 or 15.
Is the hypotenuse. So 15.67 is the hypotenuse, so that means this is the leg, this is the leg. Now, substitute the values. You have the formula, substitute the values. How is that one different from the other one?
And you subtract.
We will eventually subtract, but how do you know you're subtracting? How do you know you're subtracting?
Because you already know the hypotenuse.
You already, yeah. Okay, I'm gonna take it back to solving equations. We wanna solve for x. How do we solve for x? Isolate it, right? So, figure this out. Okay, how do you solve for x? What's next? Yeah. Can you see that the x squared got added by 57.76? To do that, you've got to undo the adding, which is subtracting. So subtract . Okay, as you can see, we're still maintaining the left side. We're maintaining the right side equal in the middle. What remains on the left side? So this is canceled. We're left with the x squared. Maintains on the right side would be yes.
If you are rounded.
Then we square root.
Yeah, don't round off too soon. Don't.
No?
Are you rounding off here?
Yeah.
Yeah, don't round it off too soon. Round it off at the end. Okay. And then finally, the next step is to get rid of the square. How do you get rid of the square?
Square root.
Square root, because the opposite of squaring is square rooting. 13.70. So rounding it off to 2 decimal places. What unit do I put in? Kilometers. So if each sides are kilometer, then this side must also be in kilometers. Okay? So. So have we solved for the third side?
Yeah.
Yeah. Is the third side always a hypotenuse? No. Not always. Not always. Yeah. So the c squared is always a hypotenuse. Okay, I'm gonna stop right there. You have some of these questions for you to try. Okay. Show your steps, show your work, and then by tomorrow, I'm gonna get the test done and hand it back to you with your report.